You know, every single time you click a button, place an order, or even just move around in the digital world, you're creating a ripple of data. Today, we're going to pull back the curtain on Apache Kafka. It's the incredible technology that acts like a central nervous system for this constant, massive flow of information. And it's what makes our modern data-driven world actually work. So, let me ask you this. Have you ever stopped to think about how a company like, say, Netflix or Uber manages to process millions upon millions of clicks, orders, and location updates every single second? That is a relentless flood of data, and you can't just handle that with a normal database. You need a very, very special kind of system to manage it. And that system, more often than not, is Apache Kafka. At its very core, it's a platform built from the ground up to handle streams of events. The best way to think of it is like a super-powered, incredibly reliable message highway for all your data. On the surface, the idea is actually pretty simple. You've got producers, these are your apps creating data, and they write messages. Kafka then stores those messages in what's called a durable log. Then you have consumers, other applications that come along and read that data whenever they're ready. But here's the absolute game changer. The data isn't just deleted after it's read. This means a bunch of different apps can all consume the exact same data for totally different reasons, completely independent of each other. It's huge. Okay, so to really get why Kafka is so powerful, we need to break it down into 5 core concepts. I promise, once you get these, you'll understand the foundation of basically any Kafka system out there. All right, first up, the broker. The broker's the workhorse. It's simply a single Kafka server. But here's the thing, you'd almost never run just one. You run a whole group of them, and we call that a cluster. This is how you handle massive loads and, maybe more importantly, make sure your system never, ever goes down. Next, we have the topic. This is all about organization. Think of it just like a folder in a giant filing cabinet. All the messages about new user signups, they go into the user signups topic. All the data about new orders, you guessed it, into the orders topic. It just keeps everything tidy and makes sense of the chaos. Now here's where Kafka gets really, really clever. Our third concept, the partition. To get that crazy speed and scale, a single topic is actually split into multiple partitions. You can think of each partition as its own mini log of messages, all in perfect order. This lets different consumers read from the same topic all at the same time. This right here, this is the secret to Kafka's incredible parallelism. Okay, so with all these messages flying around, how in the world does a consumer know where it left off? Well, that's the job of the offset. It's basically a bookmark. It's that simple. Every single message inside a partition gets a unique, sequential number, and all the consumer has to do is remember the last offset number it read. And finally, number 5, replication. This is what makes Kafka so bulletproof. See, each partition isn't just stored on one server or broker. Nope, it's copied across several of them. One of those copies is called the leader. It handles all the new messages and serves them to consumers. The others are followers, and their only job is to keep a perfect copy. The real genius here is that if the leader broker fails, one of the followers is instantly promoted to be the new leader. It's a seamless failover, which means the system stays online and you don't lose a single byte of data. All right, we've got the building blocks down. So now let's put it all together and follow a single piece of data on its journey all the way through the Kafka system, from the very beginning to the very end. So a Kafka message, which is officially called a record, is made up of a few different parts. Now, the two you really need to care about are the key and the value. The value is your actual data, the order details, the user info, whatever. The key is optional, but it is incredibly powerful. Using a key guarantees that all messages that share the same key, say the same customer ID, will always land in the same partition. This is how you make sure they get processed in the exact right order. The whole flow really just boils down to 3 simple steps. First, a producer fires off some data to a specific topic. Second, the Kafka cluster grabs it, sticks it in a partition, and gives it an offset number. And finally, a consumer just periodically asks or polls the topic saying, hey, got anything new for me since the last time I checked? It's a really elegant and super efficient process. But look, simplicity doesn't mean anything if it's not safe. And Kafka provides some really powerful guarantees to make absolutely sure your data is handled correctly and is never lost. So let's take a look at how it actually guards that data flow. When you're consuming messages, you actually have 3 different choices for how they're delivered, and each one comes with a really clear trade-off. First is at most once. It's blazing fast, but it's risky.
If your consumer crashes in the middle of processing, that message could be lost for good. The most common choice is at least once. This one guarantees the message gets delivered, but if there's a failure, you might end up processing the same message twice. And then there's exactly once. This is kind of the holy grail. It uses special transactional features to guarantee that every message is processed one time and one time only. Of course, that extra safety comes with a tiny little performance cost.
Producers get control over this stuff too, using a setting called ACKs, which is short for acknowledgments. Setting ACKs equals 0 is basically fire and forget. It's super fast, but you could lose data. ACKs equals 1 is a nice, safe balance. The producer waits for the partition leader to say, yep, got it, and then ACKs equals all is the Fort Knox option. This makes the producer wait for the leader and all of its fully caught-up followers to confirm they have the message. This guarantees 0 data loss, even if the main server fails a millisecond later.
Okay, let's talk about one of Kafka's most powerful features for scaling out your processing, the consumer group. It's a really simple idea. It's just a set of consumer applications that all work together as a team to process messages from a topic.
So here's how they work. Let's say a topic has 4 partitions. If you create a consumer group with 2 consumers, Kafka automatically splits the work. Consumer 1 will handle 2 of the partitions, and Consumer 2 will handle the other 2. But here's the truly amazing part. A completely different team, Consumer Group B, can subscribe to the exact same topic and read all the same data for a totally different purpose, like maybe running analytics, and it won't interfere with the first group at all.
Okay, enough theory. We've covered how it all works. Let's wrap this up with 4 absolutely critical design decisions you have to make when you're actually building a real system with Kafka. When you're designing with Kafka, you really have to think ahead. First, your number of partitions. You need to pick a number based on the maximum number of parallel consumers you think you will ever need because this is hard to change later. Second, for anything in production, always use a replication factor of at least 3. Just do it. It ensures high availability. Third, if you have messages that absolutely must be processed in order, you have to give them the same key. And finally, decide on your data retention policy. How long do you actually need to keep this incredibly valuable log of events? A week? A year?
And that really brings us to the core takeaway here. Kafka is not just a pipe to send messages through. It's a permanent, reliable log of everything that has ever happened in your business. It is the very foundation you need to build truly modern, responsive applications.
So, with the power to capture, store, and process every single event in real time, the possibilities are just endless. The only real question left is, what are you going to build with it? Thanks so much for joining this explainer.